Hello, everybody. We are doing some conditional statements today. This is going to be the first video of three, dealing with our introduction to logic and geometry. This is going to be mostly words rather than math-based, so it's going to be very different than what you're kind of used to with math classes. Most of the stuff we're doing doesn't have anything to do with math. It has more to do with logic. The reason for that is because when you get to higher level math, you tend to start doing proofs of things rather than just, solving for x kind of thing. So this is kind of the leeway between, hey, 2x plus 5 equals 7, into doing things like proving formulas and creating new formulas. You have to understand a bit of logic. So we are going to be talking about logic. When you grow up and do stuff, you might have to know a little bit of logic. I know like lawyers need logic. They have to do some symbolic logic. Usually it's kind of electives in college for them as far as I know, but it is good to know and understand how phrases can be translated from regular kind of sentences into if-then statements, which is what most of this is going to be about. It's very useful to have things in if-then statements, which is what we're getting to. So you'll see why in a minute, but first of all, we're going to go over some vocab and some symbols and things. So conditional statement is a statement that can be written in if-then form. So if something happens, then this will happen. It's very cause and effect. If I turn off a light, then it will get dark. Things like that. The hypothesis is the phrase immediately following. The hypothesis is the phrase immediately following the word if, and the conclusion is the phrase immediately following the word then. If you ever do science-y stuff, you hear those words as well, the hypothesis and the conclusion. Like when you do a study, the study has a hypothesis, then at the end of the study you would give a conclusion. And they're based on that, not so coincidentally, really. A hypothesis in logic is, okay, so you have this thing going on. And if this thing is going on, then what is going to happen? A whole cause and effect going on, which in most studies is what you're trying to prove. Most studies, not all. But so hypothesis and conclusion. The symbol notation, they always use P for the hypothesis. So I'll write it over here. P is hypothesis and Q is conclusion. So the symbolic thing for that is going to be a P and then an arrow and a Q. The arrow means like if then. So P arrow Q is if P then Q. It's an arrow because it is saying you're starting with P and you're going to Q. The arrow is not pointing to the left because that is not what's being said. You're not saying if Q then P. You're saying if P then Q. So you do have to make an arrow going in just one direction. There is a time where you can have it in both directions, but that's a biconditional. We're not doing that right now. It's saying you're starting with P, you're going to Q. Just like in the sentence, you're starting with a hypothesis and then you're going to the conclusion. And here's just some practice. Circle the hypothesis, underline the conclusion. And it literally is just, search for the letters if and search for the letters that spell then. And that's going to be it. If you live in Nashville, woohoo! Then you live in Tennessee. And that's it. It's just, do you know where the hypothesis is and where the conclusion is? Because you need to know what they are before you can actually do stuff with them. Symbolic notation, like I said, this thing is just going to be P, this thing would be Q, and with an if then you're just going to use an arrow. So it's just if P then Q like that. No more. In this one, if you think you got it, go ahead and try it. See if you know what the answer is going to be. If not, then, if the sum of the measures of two angles is 90 before the comma. The comma is useful to note because it is usually almost always separated by a comma. So you can always look for the comma. So the sum of the measures of two angles is 90. They are complementary angles, right? You don't use the words then and if. It's the things besides them. So if the sum of the measures of two angles is 90, then they're complementary angles. And it's just always P and Q. It's only if you start having like 3, 4, 5 different sentences that you start not using P and Q. I'm not sure why they use P and Q, but they do. There tends to be 2 reasons in math people use P and Q. This is one of them for logic. So yeah, that's it. Next up, writing conditionals. So this is when you actually have a real life kind of sentence and you're trying to make it into an if then, because you know mathematicians, they're very, well, at least most mathematicians are very purists, where they would rather have 2x plus 5 equals 7 rather than say, well, 5 more than the doubling a number is 7. You know, it's the difference between a word problem and just like a solving regular equation. And it's the same thing here, believe it or not. You're trying to take a sentence and make it into a simpler sentence that you can do stuff to, just like you would a regular math equation. It's going to look very different, but it's still going to be along that lines. So it says an obtuse angle has a measure greater than 90. And you have to change this into an if-then statement. If something, you know, I don't know how long it's going to be, then something. And you have to figure out what those things are going to be. So if an obtuse angle has a measure greater than 90, well, then there would be no conclusion because there's nothing after that. So it's not just like a whole copy-paste. You have to find out what the hypothesis is and then what the conclusion is. So it says an obtuse angle has a measure greater than 90. So it's kind of talking about 2 things. It's talking about this obtuse angle and it's talking about being greater than 90. And those are kind of the things we need to be talking about in the hypothesis versus the conclusion. You're talking about an obtuse angle and you're talking about something greater than 90. And those are going to have to go in the 2 separate places. Now, straight up, some people are better with logic than others. I have a logical mind. I'm able to do these pretty well. I don't expect you to right off the bat because you're not me. So I do have some tricks if you really struggle with kind of doing these kinds of things, which I'll talk about. But it says if an obtuse angle has a measure greater than 90. So the way you would separate it is if it is an obtuse angle, then it has a measure greater than 90 degrees. And that would be it as a conditional. If it is an obtuse angle, then its measure is greater than 90. An obtuse angle has a measure greater than 90. You would say this in a math class, right? Teacher called on you. What's obtuse angle? You go, well, an obtuse angle has a measure greater than 90. Yay, you are correct, full credit. We're just going to the next stage of writing it into if-then statements. If it is an obtuse angle, then it has a measure greater than 90. It says all numbers divisible by 4 are also divisible by 2. So you have to look for like the separation of where things happen. All numbers divisible by 4 are also divisible by 2. So it's kind of like there's a cutoff right here. All numbers divisible by 4 are also divisible by 2. So we're talking about this part right here, and then we're talking about this part right here. And if you write it as an if-then, do make sure you're using proper grammar, by the way. You're not going to write if all numbers divisible by 4. That does not make sense. If all numbers divisible by 4. You have to make it into an actual, make sensible sentence. If a number is divisible by 4. If a number is divisible by 4. Then, how would you write this into something that makes sense? Then also divisible by 2? No, you would need to say like, then it is also divisible by 2. So sometimes you have to add words in order to make it make sense grammatically. If a number is divisible by 4, then it is also divisible by 2. Okay, so I said I was going to show you like some tips if it's not making sense to you, because with me, it's like with definitions, there's the thing that you're talking about and then its definition. If the thing you're talking about, then its definition. If it's obtuse, then it's greater than 90. If it's divisible by 4, then it's divisible by 2. Like, that's how my mind thinks, and I can do that. If you're not that inclined to be able to do that, I've done a couple of researching things trying to think of a good way to describe it. And I think the word I eventually came up with was auxiliary verb. I believe when I Googled it is what it was. If you know English a lot, there are these things called auxiliary verbs, which basically help verbs transition to another thought. And that's kind of what it is. But by those, in these ones, it would be the word has and are. Basically, you know, is, has, was, were, those kinds of things separate thoughts. So if here I did an obtuse angle has, if you just cut it off here right before the auxiliary verb, this one, same thing, are, if you cut it off, that kind of separates it for you. So that might be helpful if you really struggle with it. It's not a preferable way for me, to be honest, but it is something that can help just to separate the thoughts. Obtuse angle, if obtuse angle, then greater than 90. Then you just fill in words so the English works. If number divisible by 4, then divisible by 2, add in some words to make it make sense grammatically. The way I thought about it, I'm going to do this on a separate sheet. I prepared some other stuff. The way I think about it is like the place that it separates is the place where it makes sense for you to say something like it blank or they blank. And it's like what word goes here for it to make sense, and that's where you would cut it off. Like here I started with all dogs go to heaven, right? So it's like, where exactly would you have an if-then statement in here? Because it seems very, very short. So what I'm saying here is that if you can't already, like, you know, for me, I already know it's like, okay, we're talking about dogs go to heaven. So if dog, then heaven, you know, that's just how my mind works. I can separate it. But if not, you can say, well, where does the word it or they go that makes sense? Like all, like it all, no, it dogs, it go. Well, that's kind of close. It would be they go, right? That makes sense grammatically. You could say they go to heaven, which means go is going to be the separation of the thoughts. Here it says my jokes are funny. So they are funny, right? They are funny. So putting the separation right before it is going to be the separation of the thoughts. We're talking about my jokes, and the conclusion is they're funny. Duh. In the next one, cheese that doesn't belong to you is called nacho cheese. And it's like, well, where does it go? It's like, it that, it doesn't, maybe they doesn't. And it's actually this one right here. It is, right? It is. So you would separate the thoughts here right before the word is. If you have cheese that doesn't belong to you, then it is called nacho cheese. So you can look for those things where it would make sense, right? It belong, it to, it you, no, but it is. Those kinds of words. So like is, has, just those kinds of words. that separate two thoughts. So this would be like all dogs would just be, if it is a dog, then, and then here's the second part. It goes to heaven. That's a movie, by the way, if you didn't know. All dogs go to heaven. My jokes. If I tell a joke, then it is funny. Woohoo! And then finally, if cheese doesn't belong to you, then it is called nacho cheese. Yeah, if cheese doesn't belong to you, then it is called nacho cheese. Yay! There you go. Okay, I think that's all I need to talk about for this video because we are getting to 16 minutes. So, yeah, we'll just pick up with the other thing there. So, see you on the next one.